Hello and welcome to this video. Today I'm going to talk about DMS scheduling or deadline monotonic scheduling. Over here, one of our standard assumptions is that the deadline of a task is equal to the period. Now we relax this assumption and allow deadlines that differ from the task period. For these kinds of task sets, another fixed priority scheduling policy was developed. The so-called deadline monotonic scheduling, DMS. Schedule the following task set with RMS and DMS, and what you can state about the ability of the policies in regard to task sets with a deadline different than the period. Over here I'm going to use this tool to help me draw my patterns or draw my schedule. I will leave you a link in the description box where you can use it also. First, I'm going to change the number of tasks to 3, time units from 30 to 24. Then I will start with RMS scheduling. And with this algorithm or this policy, the task with the shorter period gets the higher priority. So T1 will be first or executes first, then T2, then T3. Over here, I'm going to start by adding a period line at 6, then 12, 18, and 24. And for task 2, 8, 16, and then 24. T3, 12, and then 24. Next, I will place the deadline. So the next is the execution time, and the third is the deadline. So over here is 6. I'm going to click Add Deadline at 6. Like that. And for T2, the deadline is 5. So like that. And for T3, 4. Okay, so next I'm going to hit draw mode and start with T1. T1 executes for 1 time unit. Then T2 executes for 2 time units. And then we have task 3 for 3 time units. 1, 2, 3. And we can see that we missed the deadline here, but we didn't miss the period. At time unit 6, we have a new job for task 1. At time unit 7, we cannot execute T2 again because it has finished. So, as well as T3 also. So in 7, we'll have an idle time. At time unit 8, T2 second job releases. So 1, 2. And we'll have another idle time at 10. At time 12, we'll execute T1 first because it has the shorter deadline for 1 time unit. Then T2 has done, so we'll execute the second job of T3. So 1, 2, 3. The third job of T2 releases, so 1, 2, and then at time unit 18 we'll execute T1 because it releases here. At T19 all of the tasks have finished, so we'll have an idle time until 24. Okay, so this was RMS schedule. We can tell that T1 doesn't miss any of the deadline or the period, as well as T2, but the first job of task 3 misses the deadline. Now we'll check with DMS and see the difference. I'm going to click Delete Tool and delete the rectangles of the tasks over here, and make sure I don't delete the deadlines or the period lines. Okay, so in DMS algorithm, the task with the shorter deadline gets the higher priority. So here, task 3 executes first, then task 2, then task 1. I'll click draw mode, then execute T3 for 3 time units, then T2 for 2 time units, then T1. At time unit 6, T2 and T3 have finished their jobs, but T1 releases, so I can execute it here. At time unit 7, all of the jobs have finished their execution, so we'll have an idle time. Over here, T2 will execute because T3 also have done executing the first job. So 1, 2, and we'll have an idle time also at time unit 10. At time unit 12, T3 executes first, then T2 has done the second job, but T1 already released the third job and waiting for its turn. So one over there, and then we can execute T2 over here because T3 is done and it's T2 turn. At time unit 18, we'll execute T1, and from 19 onwards, we'll have an idle time. So it's obvious over here that DMS didn't miss neither the deadline, neither the period, and that what we can say about the ability of the policy in regard to task sets with deadline different than period. So when they differ from each other, RMS is no longer optimal. Instead, DMS performs better. So if a task set can be scheduled by any fixed priority algorithm, DMS will succeed, whereas RMS may completely fail. I hope this video helps. You can download the graph from this button and have it saved in your PC. If you like this video, give it a thumbs up, subscribe to my channel, and I'll see you in the next video.